you going to do like each one?
Tell whether the function represents exponential growth or decay for 1 through 3 on the review. So number 1 states f of x equals 4.25 to the x. Now, when you're dealing with exponentials, in order to know if it's growth, your base has to be greater than 1. If you want to know if it's decay, your base has to be between 0 and 1. So for this particular model, what number's in the base? 4.25. Is 4.25 growth or decay? Growth. So my answer is growth. Now, it's going to also ask you, which I didn't put that on the directions, it's going to say, tell me why, or explain. The explanation is as simple as b is greater than 1. Like, that's the explanation. Number 2. Bless you.
Thank you.
Y equals 3/8 to the x. Is that growth or decay? Decay. Why is it decay? Because b is less than 1 but greater than 0. Okay, it's 3/8. Now, the other thing we also had between growth and decay was in section 2, where we dealt with e, the natural number. If your e is to a positive exponent, you are in the growth category. If your e is to a negative exponent, you are in the decay category. So if you see e to a positive exponent, you are in the growth. If you see e to a negative, you are in the decay family. So number 3 says y equals e to the 0.6x. Is that growth or decay? Growth. Why?
Positive.
It's a positive exponent. That's it. So on 1 through 3 of the review, see how long that took you? Not very long, was it?
Nope.
And on your test, there are 2 of them. On your test, there are 2 questions that look like this.
Which 2?
2 out of how many?
Well, we just had, oh, you mean on the whole test?
Yeah.
You'll get there. So the first 2 questions are going to be just like these. 1 and 2. How do you guys feel about those? Pretty easy? I hope so. Now, on the next set of directions, it says simplify the expression. Now, I can only fit 3 of them on there without having to have any room for me to work. Okay, so simplifying the expression, remember, means we're dealing with the exponents. When you are multiplying like bases on the top one, what do you do with the exponents? Add them together. So what is my final answer? E to the 12th. Good job. When you are dividing on the next one, on number 5, the first thing that you have to do is you have to then simplify the 15 divided by 3. What's 15 divided by 3? 5. Nice work. And then for the e's, you subtract them. So how many would you have? E squared or e to the 2, right? And on that particular thing, what I would do for me personally is I always like to look at who has more, the top or the bottom, and by how many more. That's the question I always ask myself. Because let's say the bottom would have had e to the 6th. Then I would have left the e in the bottom with an exponent of 3. Like I would have just subtracted them, but left the exponent where it's positive. Okay?
So it still would have been
5 and then over e to the,
okay.
if it would have been the e bigger on the bottom. Now, the next one, number 6 on the review. This one, I've got people to get wrong quite a bit because they don't do it the right way. When you have a 5 times e to the 4x raised to the 3rd power Most people do not distribute the exponent like they should, and they miss the 5 to the third to begin with. So that should go 5 to the third times e to the what? What's 4x to the third? 12x. Then to clean it up a little bit, what's 5 to the third power? 125. E to the 12x. Now, what most people get wrong with a problem like that is they tell me it's 5e to the 12x. They get the e part right, but not the 5. So be careful. Okay, that's 4, 5, and 6 on the screen right now. Okay, on to 7. E to the ln of 9, 8, log of 7, 49 to the x, and 9, log of 3, 81 to the negative 2x. On number 7, when you have e and ln right next to each other, they cancel each other out. So that means that these two parts right here cancel each other out, and you're left with whatever number was in that spot. So what's my answer? 9. And you're done. Also, it would also go the other way. If you had the ln of e to the 9th, then the ln and e would cancel each other out, and you're still left with 9. Okay? What do you guys think of that one? Easy? Good. Now the next two are very similar to each other. And we had problems like this, and they're very similar actually to the ones that are still on the board from last Friday over on the far left side. But I'm going to do them a little bit differently, more like in the middle of the board. What I want to do is I want to take the bigger numbers and rewrite them into the same bases as the base that we have. So for instance, when I have 49 in that location, I want to make that as 7 to the somethings.
7 to the second.
7 to the second power gives you 49, right? Because 7 times 7? Good. So what I'm going to do is I'm going to rewrite that log to be log base 7, 7 squared, but then there was an x up there. The 2 that you created because of 7 squared and the x multiply with each other to give you 2x. Now, the way that this works out from here is if your bases are the same, meaning those two numbers that I'm pointing at are the same, they cancel each other out, and you're left with just 2x. The log goes away. So the answer is just 2x. I'm going to do the same thing on the bottom one. 81 is 3 to what power? 3 times 3 is 9. Times 3 is 27. Times 3 is 81. So I need how many 3's total? 4. So that becomes log base 3, 3 to the 4th, times negative 2x. You multiply the exponents together when it's coming upstairs like that. What's 4 times negative 2x? Good. And if I have it like that, if the bases are the same, what do? Cancel, and what are you left with? You have just now accomplished 4 through 9 on the review, where the directions say simplify the expression. On your test, questions 3 through 6 says simplify the expression. Same directions, same types of looking problems. On the review, we had 6 of them. On the test, there's 4 of them. Okay? How are we doing so far? 3 through 6. Number 10. As log base 4, 1024 equals 5. Number 11. has log base 1/3, 27 equals -3. 12 has 7 to the 4th equals 2,401. And 13 has 4 to the -2nd equals 0.0625. The directions for 10 through 13 say rewrite the expression in exponential or logarithmic form. So what that means is if it's got a log in the problem, you want to write it in exponential. If it doesn't have a log in it, you want to write it with one. That's the key. Now, on the review, 10 through 13 is the same directions as 7 and 8 on your test. So on the test, 7 and 8 say rewrite the expression in exponential or logarithmic form. On the review, we gave you 4 to practice. On the test, there's only 2. Now, here's how we do this, and I don't know if you guys forgot about how to do this or not, but here's what it goes. On the top one, what's the base number? 4. And remember how we went through this one and you guys kind of liked it, where I looped around, picked up the exponent, which was how big? Equals. So 4 to the 5th equals how much? And that's your answer. There's nothing more to do. You're not solving anything. You're not finding an x. You're just rewriting. So help me out with the next one, number 11. What would I write?
1/3 to the -3rd.
1/3 to the -3rd equals 27. On number 12, now we're going backwards. So we're putting a log back in on the fire.
Log 7.
So log base 7,
2401
2401 equals 4. And again, you start with the base and work your way around the loop. So what's the last one? Log base 4 equals -2. I hope that those 2 questions on your test like that are going to be pretty easy. 7 and 8 on your test look like these problems. Okay? So I want you to think about that because I think you're pretty smart. If I said that 7 and 8 were like this, and if we did 4 of them, 2 of which we converted to exponential and 2 of which we converted to log, and on your test there's only 2 total, I'll let you figure that out. Okay? How are we doing so far? Not too bad? Number 14 has log of 45. 15 has the ln of 1.4. And 16 has the log base 232. And the directions say evaluate the logarithm, round your answer to 3 decimal places if possible. I forgot to put the if possible part, but you get it.
So you can do it with the first 2.
On the first one, all you do, you guys, is type in your calculator log 45, enter. And then you write down the number that came out. How much?
1.6.
And you're done. You simply type in log 45, enter, and then write down the number that came out. The next one, you type in the ln of 1.4, enter, and write down the number that came out.
Or 5.
0.33 what?
6.5.
65?
Yeah, because there's a 7. It's like 4 7.
What is it?
Yeah, just keep. You're good.
Okay. Done. How do you feel about those 2?
Good.
Now the last one that's on here, you wouldn't be able to use a calculator because remember, they're not base 10. So this is like what's on the board over there to the very far left, where we took and set it equal to x, and we rewrote it. So what number did we start at? The 2. and rewrite it to be 2 to the what equals what? And when I give you these in this part of the chapter, every single one of the big numbers can be rewritten as the smaller number to some power. 32 is 2 to the what power? Yes. And if you're unsure, count. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. That was 5 of them. So if the bases are the same, the exponent should be the same. So x is equal to what? 5. How you guys doing with those three?
What numbers are those?
On the test, questions 9 through 11 look like those. And on that front page of the review, we've just accomplished the same looking types of questions like the front page of your test. Okay? You are more than 2/3 of the way done with your test right now. And it's taken us 16 minutes to talk about it so far. Okay? Then, if I turn the page, 17 and 18 on the review say graph the function and its inverse. So on 17, I have f of x equals the log base 3x. So first of all, this goes back to what I talked about at the beginning of the day. With the base being a 3, would that be a growth or decay log function? Good. So growth goes uphill and comes out this way. That's my initial one. In green, to find the inverse, our steps were replace f of x with y. Oh, I have to do it here. Y equals log base 3x. Step 2, switch x and y around. So what should I have? Log 3y. Step 3, solve for y. In order to do a log, you need to convert it back into an exponential. So what is the base number? 3 raised to the x equals
Y.
So 3 to the x equals y. You just found the inverse. How do you graph an exponential growth problem? Some of you will put it into your graphing calculator, and there's nothing wrong with that. What number should it go through? 0, 1 should go through here. And growth should go uphill. The thing I was trying to show you yesterday was to show you that they are mirrored images of each other over a different line. It's not over like an axis, for instance. That's what I was trying to show you with that whole stuff yesterday. According to the directions, it says to graph the function and its inverse. Is that what I just did? Do I have both pictures on there? Yes, I do. Now, shame on the book for this. I want you to look at number 18. I wrote these right out of the book. I didn't change it. But here's what I want you to think about for 18. It's the same answer as 17. Because the initial formula, or the initial problem in exponential form is right on the screen. It's the same thing. So here's what I'm proposing. Do you want me to change the base on that and do a different one?
No.
I heard yes by some people, so I will. So on 18, for instance, I'll do a decay one, so that way you guys see one of those. I'm changing 18's base so that it's not the same answer as 17. Would this be growth or decay?
Decay.
Why? Very proud of you guys. Good job. So that's my exponential decay problem. That's exponential decay. Now, to find the inverse, we need to change it into log form after we do the switch and stuff. So what would I do first for my first step?
Log 1/2 x.
Y equals 1/2 to the x.
Log 1/2 x.
Switch the x and the y. Now rewrite it. So log, what's the base number? 1/2 x equals y. So I start here, and I'm going to work my way around. Now, is the log, because it's a base of 1/2, growth or decay? It's still decay. Here's the difference. They are going to look very similar, but they're going to be in different locations, very minimal. Remember, this went through the ordered pair of 0, 1. The logs have to go through 1, 0. So this one's going to go through here. And remember, if it's decay, it's got to come from the top and work its way down. So are they going to look like the same, just in different locations? Yes. They will. That's the difference between these two. Okay? Emily?
So when you're doing decay, you're going to put it into log form?
If I'm in exponential, I'm going to put it in log form.
Yeah, why'd you put it?
If it's in exponential, I put it in log form.
On the, when you put the parent function, didn't you show us that?
Yeah.
But it wasn't beneath.
That's not the parent one for this, though. That's not a log for the parent. The green one would be like that one that you have on your page right now, because it's log. The black one is exponential from like
Can you show
section
us
1.
that exponential?
After we get done with the worksheet, sure.
So this is log.
Okay, so that's the new 18 if you think about it. How we doing? On your test, questions 12 and 13 are like those. So on your test, questions 12 and 13 are like those. Number 19 has f of x equals e to the negative x, and g of x equals e to the negative 5x minus 8. Now, to talk about this one and show a little bit, when there's a negative in front of the x like this up in the exponent and your base is e, that's trying to tell you if it's an exponential growth or decay. Not necessarily a flip over the y-axis, although it would. Since the exponent is negative, that's a decay. So the first one that I'm going to draw up there on my directions, it says to graph both. I know it also says some other things, but graph both. E to the negative x would be this one that comes down here and swings that way. That would be exponential decay. On the green problem, what transformations take place? I got a down 8 for sure. And I have a horizontal shrink by 1/5. What a horizontal shrink does is it smooshes it this way, horizontally, right? So what's going to happen to the curve? Is it going to be more gradual or tighter, like a sharper turn? Tighter, right? I also have to move it down 8. 1, 2, 3, 4, 5, 6, 7, 8. So it should come down in here, hit it, and go out tighter. That's number 19. '20 has f of x equals the log base 4x, g of x equals 1/2 log base 4 x plus 5. Is my base a growth or decay? A growth, but in log growth. So that comes up from the bottom, from the depths, and goes out to the right. That's the parent. So what transformations take place?
Stretch by half.
We got a vertical shrink by half, and left 5. Because it is in parentheses. If it wouldn't have been in parentheses, that would have been an up 5. So be careful. If I shrink something vertically, that means it's going to get tighter to the x-axis. I also have to move it to the left 5 units. 1, 2, 3, 4, 5. And it should have been narrower. It's an exponent is. Exponent is inside. And if it's got a log in front of it, then they'll have parentheses. You won't have an exponent for logs. Okay. So 19 and 20 on your review is just like number 14 on your test.
What about 17 and 18?
It was just like 12 and 13.
17 and 18 are like 12 and 13.
17 and 18 was like 12 through 13 on your test. 19 and 20 is like 14 on your test. And last, but definitely not least, number 21. You purchase an antique lamp for 150 bucks. The lamp increases by 2.15% each year. Write an exponential model. So, in chapter 1, or section 1, sorry, you had two different formulas. You had plus r to the t, or you had minus r to the t, where one was dealing with increasing and one was dealing with decreasing. For our problem, is it an increase or decrease?
Increase.
So which one are we using?
Plus.
The plus, the first one. A stands for the what?
150 initial price.
Initial amount. So we bought the lamp for 150 bucks. 1 plus. When we put the rate in there, how do we put it in there? Decimal form.
0.025. Or 0.0215.
If it would have been the other one, now and then I would subtract it. But for this, what is 1 plus 0.0125?
1.0215.
So on the problem, it says to write an exponential model describing the value of the lamp. You just did it. It did not say to figure out what the value of the lamp was 50 years from now. Although it might, it could, I don't know.
It's just as simple as plugging it in at that point.
But what you would do if it said how much is the lamp worth 50 years from now, you'd put 50 in for t and see what comes out. That is like number 15 on your test. The last question. So, I have also been asked to do this one more time. So I want to put it on here. If your base is greater than 1 and you are an exponential, like b to the x, the parent is going this way. If your b is between 0 and 1, that's exponential decay, so that's coming down the curve. I was also asked to put those up there for parents. This would also be the same as e to the x, and this would be the same as e to the negative x. Okay? Now again, make sure you take the time and make a note card. Okay? Any other questions you guys want me to go through?
Please don't.
Tomorrow.